Good day, students. Welcome to this second tutorial. Today the topic is simple linear regression, and I opened the data file which you're gonna use during this tutorial. So this is it. Names of cities, districts, the number of inhabitants, the degree of urbanization, and the degree of people living on social security. So how should we read this? In Almere, which is district 2, has, let's say, a little over 90,000 people who live there, a degree of urbanization, and let's say a small 20% of the people live on social welfare. Okay, for instance, if you want to find a relation, for instance, between the number of people who live in a city and the percentage of people who live on social security. You could say, for instance, you have this intuition that you think people in big cities live more on welfare than, let's say, in small cities because of community structure, whatever. So this, if you want to, let's say, investigate this, how should you do this? Now, our topic is simple linear regression, so let's do it. We go to analyze, regression, linear, and let's say the number of people or the percentage of people living on social security, SOC-SEC, this is our variable, is the variable which we want to explain. And we want to explain it by, let's say, the number of people who live in a certain city. So this is our dependent and this is our independent variable. We just keep it on the enter mode, and I would advise you to keep it always on this enter mode because this is the most plausible way to do regression. The enter mode. Maybe we want to have some statistics. For instance, we want to have some descriptives. The other terms like Durbin and Watson, collinearity diagnostics, yeah, we didn't discuss that yet, so these are the things I think are feasible to click on. Continue. Do we want to have certain plots? No. Yeah, we want to save certain stuff, and let's say we want to have the unstandardized predicted values, the unstandardized residuals, and the standardized residuals. I think these will come in handy, and let's click on continue. Other options, no, we do everything, let's say, with 95%, so let's continue. If we click on OK, SPSS will generate an output, and this is our output. First of all, the mean for both variables, for, let's say, the average percentage of people living on welfare of these cities is, let's say, almost 25%. Let's say the average inhabitants of cities are, let's say, a little over 120,000, but let's go on. I don't want to involve myself now with these correlations, but you see here there is a correlation between the two. Let's say 0.4 is the correlation. So this is not very strong, but it's also not very weak. So this is somewhat in between, and we will discuss this later. Now for the linear regression. First of all, R square, let's say a little over 16%. And how is this value to be interpreted? Let's say 16.5% of all variance around the average of, let's say, SOC-SEC, the people living on social security. 16.5% of that is explained by the variable, the number of people that live there. Okay, so here we have our ANOVA. So this analysis of variance, and everybody probably knows how to read this. This is the most important number here. So we can reject the initial hypothesis because there are more, or let's say at least one of the betas is significant with 95%. Here we see it again. This thing also the b itself, the standard error of the b, the beta, the standardized coefficient, the t-value, this number divided by this number will give us our t-value, and we see this is significant with 95% certainty. So this model explains, and this is how you do linear regression. This is the way to do it. And for you now it's the deal how to interpret these values. But probably in your lessons from Dimitri you should have gotten that. So it's not that difficult. This is probably the simplest tutorial of the tutorials we had yet. So okay, yeah, there are other things maybe that you should know. For instance, this standardized beta, this unitless beta, is the same as the correlation coefficient. Everybody should know this now. Another thing you should know, this 0.406 squared is the same as the r square. So with simple linear regression there is a direct relation between the correlation coefficient and r square. Other things you should know. Yeah, I can tell you another trick. This number here, this t value squared, is exactly the same as this f value. This is only with simple regression, because this f tests whether all betas or all b's are 0, but all b's with simple regression is just one b, because there are no more independent variables. So this is just the root of this is this number, or the square of this is this number. So okay, let's click it away. Another thing I want to do, if you now look at our data set, you see there are new values created. These are the predicted values, these are the residuals, and these are the standardized residuals. How should this be interpreted? So we clicked within the SPSS button, we clicked on save certain values. Now we have saved the predictions, the residuals, and the standardized values. So this prediction, how should it be seen? In that sense, we just saw the coefficients of the line, and if you make a prediction with this line, for instance, you plug in 91,000 inhabitants, the prediction would be there is, let's say, a little under 24% of people living on Social Security, while actually there were 19% of the people living in Almere on Social Security. So our residual is the difference between those two. And the standardized residual means we just divide it also by the standard deviation. So the standardized residuals are very handy in that form. They are always with 99% certainty between -3 and 3. You should know this about these standardized, these z-scores. You can also call them z-scores. Okay, so again, for instance, if you look at Amsterdam, and if you look at Amsterdam, they want to make a prediction. So we had this equation we just saw in our output, and you plug in, let's say, 720,000 inhabitants. The prediction would be for the percentage of people living on Social Security, let's say a little over 36%, while actually in Amsterdam 34% is living on welfare. So this is our residual, the difference between those two numbers, the actual number and the prediction. So this is the residual, and standardized residual is again this z-score, so we divide things by the standard deviation. This is how it should be seen, and these things can be very handy. So you can, for instance, look for outliers. If there are numbers, for instance, with these standardized residuals, let's say larger than 2 or larger than 2.5, you can, let's say, view them as residuals, or residuals as outliers, excuse me. Okay, I will finish now for here because I just spent almost 10 minutes on this film. Thank you for your attention.